Alright, so here we're going to have a look at IP address classes. Remember, an IP address is 32 bits long. Alright, if you look at the top of the screen, you can see there are 32 ones, alright, representing a 32-bit IP address. We don't normally see it like this, obviously. Normally when you see an IP address, it looks more like something like 192.168.0.1. Alright, so you have 4 decimal numbers separated by periods, but that is actually a 32-bit IP address. Those 32 bits are broken up into octets. So if you look at the top of the screen there, you can see I've broken this up into 4 octets. Right? Each octet can have a decimal value between 0 and 255. Why between 0 and 255? Very straightforward. If you remember from our previous lesson where we looked at our 8 bits in our binary conversions, right? There's our 8 bits, right? You can have any number that starts with 0, 0, 0, 0, 0, 0, 0, 0, which obviously gives you 0, right? And your maximum number you can create with those 8 bits is 1, 1, 1, 1, 1, 1, 1, 1, which is equal to 255. Alright, so any IP address can always, only have numbers between 0 and 255. If you get a number over 255, you know there's a problem with your IP address. Alright, so very straightforward. That's what an IP address looks like. Let's have a look at the different classes of IP addresses. Alright, so we're back to our binary decimal conversion table of 8 bits. And I'm going to show you why that's important just now. Right, your class A IP addresses go from 0 to 127. All right, now when you're looking at an IP address and you want to determine what class of IP address is, you look at the first octet. If the number is between 0 and 127, it is a class A address. Similarly, class B will be from 128 to 191, and class C is from 192 to 223. So if I gave you an IP address 192.168.0.1, all you do is you look at the first octet, which in this case is 192. 192 fits in with the class C. Right, as a result, this is a class C address. If I gave you something like 172.16.28.10 as an example, right, again, you look at the first octet, this fits in this range, right, as a result, this is a class B IP address. Now, it looks like it's very difficult to actually remember this, but it's not at all, right? Very simply, your class A starts at 0, right? Your class B starts at 128, right? Obviously, if class B starts at 128, class A is going to end at 127. All right, class C starts at 192. Easy way to remember this. 2 bits, 128 plus 64 gives you 192. All right, and if class C starts at 192, then class B must end at 191. All right, class D, by the way, will start at 224, which if you look up here, 128 plus 64 plus 32 will give you 224. Now, we're not going to worry about class D for now. It's a multicast address range, and we'll look at class D and possibly class E a little later on. All right, for now, all you need to know is about class A, B, and C. And very easy way to remember it if you've got this table at the top here. All right, so class A, 0 to 127, B, 128 to 191, and class C, 192 to 223. Now, something that is important for you to remember is that 127 is a special address, right? 127 is generally used for loopback testing. So those of you familiar with loopback testing, if you ping 127.0.0.1. Right, that performs a loopback test to just see whether TCP/IP is functioning correctly on your network card. So in the real world, we don't really use 127 in a Class A, even though it is a Class A address. Right, Class A really goes from 0 to 126. Alright, just remember, it does go up to 127, but we don't really use 127 because it's used for loopback testing. Alright, let's look at the subnet masks associated with Class A, B, and C. Alright, so Class A, the default subnet mask is 255. Not 0.0.0. Alright, Class B, 255.255.0.0, and Class C, 255.255.255.0. Sorry about my terrible handwriting. So if you have a look at the top of the screen there, you can see that I've written out the binary representation for these subnet masks. All ones being 255, right? And all zeros obviously being 0. Right, this is important because once we get to actually subnetting these addresses, right, we'll be looking at how these binary digits work. Now, the first portion, or the ones in a subnet mask, are the network portion. So the network portion, right, for Class A is only the first octet. And as you can see in Class B, the second octet is also network. So you've got 2 network octets. And in Class C, you've got 3 network octets. Right. The zeros that are left behind are your host octets. So in Class A, you've got 3 host octets. Right. In Class B, you've got 2 host octets. And in Class C, you've only got 1 host octet. All right, what that means is that Class A addresses have fewer networks, right, but lots of hosts. All right, Class B have an average number or an almost equal number of networks and hosts, and Class C has lots of networks, but fewer hosts per network. And we're going to have a look at how this works in our next video. For now, it's important just to know the different classes, right? Which portions are host and network addresses, and why we have our default subnet masks and how to represent them in binary. Right? Please make sure you also learn the different ways to identify Class A, B, and C. Remember, all you do is look at the first octet, right, and see where it fits in the scale, right? And that's how you will tell whether it's a Class A, B, or C. All right, we're going to look at this in a little more detail in the next video.